Hello everyone, welcome to our next lesson. Today we're looking at double angle formulas. These formulas are useful as far as solving equations or simplifying relationships. So let's just look at them. Our formulas are, we've got sine 2 theta equals 2 sine theta cosine theta. And then cosine 2 theta, well, there's three different possible ways of playing around with it. You've got cosine squared theta minus sine squared theta, 1 minus 2 sine squared theta, and 2 cosine squared theta minus 1. Let's just look at the first one just to get a feel for it. So you've got 2 sine theta. Well, first of all, we know that sine of pi over 6 is equal to 1 over 2. And we also know that sine of 2 pi over 6, or pi over 3, is equal to root 3 over 2. So, let's just see the formula. Sine of 2 times pi over 6 is equal to, using the formula, is 2 sine pi over 6 cosine pi over 6. And let's just see if this answer comes to what we believe should be root 3 over 2. Well, sine of pi over 6 is 1 over 2, and cosine pi over 6, cosine pi over 6 is equal to root 3 over 2. And these two cancel out, and we get, what we were hoping for is the final answer of root 3 over 2. So this is not a proof, but at least it gives you a better feel for what the formula is all about. Typical questions you would see from IB would be something like this, where sine x is equal to 5 over 13, and it wants you to figure out what is sine 2x. Well, if you've got a sine as positive, you know it's going this way or this way. So there could be two answers to this question. So if sine x is equal to 5 over 13, well, one method that you could do is you can look at the triangle, and then you've got 5 over 13, sine x equals 5 over 13 using SOHCAHTOA. And then using Pythagoras, 13 squared minus 5 squared is equal to x squared. You find that x is equal to 12. Now if I want to find what sine 2x is, well, sine 2x is equal to 2 times sine x, which is 5 over 13, times cosine x. Now cosine x is 12 over 13, but it also could be negative 12 over 13, because it's this triangle where you're at negative 12, or this triangle where you're at 12. So there is two possible ways of getting the answer to this question. Multiplying them out, 12 times 10, 120, 120 over 169, and it's plus or minus. You may need to simplify it, but there's the answer. Another way that you could look at this question is you could realize that sine squared x plus cosine squared x is equal to 1. And if sine x is 5 over 13 and cosine squared x is equal to 1, then cosine squared x is equal to, let's make that 169 over 169, minus 25 over 169, and then cosine squared x is equal to 144 over 169, and therefore cosine x is equal to 12 over 13 plus or minus. This would get us the same answer as before, and we can solve for sine 2x. Another way that we can answer one of these question that could be asked is you get something like this, where cosine x plus cosine 2x is equal to 1, and it wants you to solve for x. So your options are, you could change cosine 2x to this, where you got sines and cosines. I don't know how that would help. Or you could change it into this, but once again, your equation will have sines and cosines, so I don't know if that's useful. So let's try the third one. This change was cosine x. Your cosine 2x would be the same as 2 cosine squared x minus 1 is equal to 1. Keep going. This becomes 2 cosine squared x plus cosine x minus 2 is equal to 0. And look at that, it turns into a quadratic. Now we go back to what we've done in the past, where we say let cosine x is equal to u, or some letter. So 2u squared plus u minus 2 is equal to 0. Solve the quadratic, then sub cosine x back in, and then solve for x. Hope this helps. Have a good day.